Greetings, chemistry students. Mr. Resentis. I'm on chapter 13, so follow along. We're talking about gases. Primarily, we're just going to deal with the ideal gas law. But before we talk about the ideal gas law, you have to go back and read the kinetic molecular theory of gases, the 6 postulates. I believe there's 6 or 8 postulates. Each one is important in understanding why the gas laws work. So when we read things like the average kinetic energy of molecules is proportional to the absolute temperature, well, that's Charles' law. These laws are the kinetic molecular theory of the gases. Now, Charles' law is part of the ideal gas law. The ideal gas law is PV equals nRT. So it's Charles' law. That's part of the ideal gas law. It's Boyle's law. Boyle's law, if you recall, is P is inversely proportional to V. Charles' law is V is directly proportional to T. Avogadro's law is V is directly proportional to the number of moles. So we understand these individually, and then we bring them all together for the ideal gas law. All right, and so this is a culmination of these 3 gas laws. So you have to go back and recognize that this is a culmination of understanding. This isn't a starting point, but perhaps the ending of your studies of the gas laws, because it's adding them all together. All right? Now, with this PV equals nRT, let's talk about the variables. The first variable that you have to understand is the R constant. Now, the R constant, you have to recognize that the R constant, what it does is it takes the standard temperature, which is 273, the standard pressure, which is 1 atmosphere, the 1 mole, which is standard, the STP, and with 1 mole comes 22.4 liters. And so all of these variables are PV equals nRT. And so what do we get for our R value? Well, we get 0.0821, and that is our R value if we use atmospheres. However, if we don't use atmospheres but we use pascals, and pascals are Newton meters, that's what a pascal is. So if we use pascals, which is 101 kilopascals, or 101,325 pascals, we just do the exact same equation, we don't get 0.08, we get 8.31. So if we're going to use pascals, we use this R value, 8.314, and if we use atmospheres, we use 0.0825, excuse me. So these are where the R values come from in our PV equals nRT equation. The pressure could be in atmospheres, torrs, pascals, or millimeters of mercury. Volume could be in liters or meters squared, meters cubed or centimeters cubed. Moles doesn't have a unit. Temperature must be in Kelvin, and the gas constant, well, I just mentioned. All right, so atmospheres is ATM. These are units of pressure. Atmospheres are ATM. Millimeters of mercury, mmHg, and that's equivalent to 760 millimeters. That's 1 atmosphere. a torr, which a torr is named after Torricelli, which is the guy who invented the barometer. It's really been replaced by just calling it an atmosphere. I don't ever remember using torrs working in the lab. Pascals is, as I said, is 101,326. Newton meters, kilo, you just move the decimal 3 places to the left. Bars is another unit. I don't believe it's going to show up. And then millibars, you would just move the decimal. So these are possible units for atmosphere, for pressure. So you need to be able to recognize the units so that you can plug it into the variable, and once you do that, then you're ready to work a problem. So we could first start with an example. Here's an example, and make sure you recognize that we're dealing with the ideal gas law. PV equals NR. It's small n for nRT. So P equals pressure, V equals volume, N equals mole. R is the R value that I just mentioned. T is for temperature in Kelvin. Right. So you're going to need to be able to rearrange this equation depending on what we need. For example, if you want volume, you might need to rearrange it. The volume equals nRT divided by P. All right, so you might need to rearrange that equation. For example, it says what is the volume here? So obviously we're going to have to use this. Alright, so just depending on what it is you're looking for, be prepared to rearrange it. This is easy enough to remember. Okay, so the first step in dealing with a problem is reading it, and understanding the gas laws and understanding the units helps you in solving the problem. So that's why I say go back to the gas laws, go back to the units and understand what these units mean, and that'll help you put the pieces together to fit it in. Alright, so we have 5 grams of neon is at 0.33 atmospheres and at a temperature of 35 degrees Celsius. What's the volume? So let's just write down what we're given. Alright, so we're given, and we'll put it in the letters that correspond to our formula, so that'll help us understand. So 0.337 atmospheres, we're given that. Volume, we don't know that. That's what we're looking for, so I'll put a question mark there. We have mass. Well, I'll write it down and we'll write it down and we'll give it a think here in a minute. R, what R value? Well, because we're dealing in atmospheres, then our R value is, because we dealt with atmosphere, our R value is going to be 0.08. Remember, when we deal in pascals, it's going to be the other, but we're dealing in atmospheres, so it's going to be 0.082. And our temperature equals 35 degrees C. Well, we might need to rewrite this, so I'm going to give this a little think here. Is this one okay? Yeah, atmospheres is fine. I think we'll be able to work with atmospheres in our equation. This is what we're looking for. We don't have moles, but we do have grams, so we can convert. So convert if needed. Alright, so that would be our second step. Alright, so here's would be our first step, and here's our second step. We're going to convert if needed. So let's see here. Convert. Well, it looks like we're going to have to convert this to moles. So I'm going to take 5.0 grams of neon, and I'm going to get the gram formula mass and look that up on the periodic table. I think it's 20.18. Yeah. 20.18 grams per 1 mole, and that's going to give me 0.25 moles. All right. So now that we have the moles, I'll put this 0.25 moles up here and give it a tick. That I think I'm ready to go with that one. R value, we don't have a problem with that. Temperature, big red flag, Celsius. We want Kelvin, don't we? So I'm just going to take the 35 plus 273, and I'm going to get 308. And so Now I think we're ready to go. So what we'll do is we'll take and plug it into our equation. This is our equation, V equals nRT over P. So all we're going to do is just plug the numbers in, right? So starting with n, I guess just working from left to right, I'm going to put a parentheses here because that's what you need to put in your calculator. So it's going to be 0.25 because that's our n, right? Times, that's not a decimal, that's times, too lazy to write a big X, 0.82, right? That's our R value, we already said, 0.082, my apologies, and then our T value is, we just calculated that, is 308. Yeah? Now in parentheses, divided by the P value, which is, P is our atmospheres, 0.337, right? Okay, so if you plug this into your calculator using the parentheses, I don't think there'll be a hitch. V should equal 19, and the units are liters. Okay, so give that a go and see if you can get 19. See if you get 19. I believe you will. Simple enough. All right. The only snafu might be the conversion when you look at it. So let's take a look at this second one and see if we can identify any conversions or anything that might stand in the way of us. All right. So what are we given? We're given P equals 143.5 atmospheres. So let's guess. What is a gas's temperature? It's in Celsius. We're looking for a temperature in Celsius when it has a volume of 25 liters, 203 moles at 100. I just looked up and saw the atmospheres, and I didn't even read the whole thing out. What is the gas's temperature in Celsius? So we want our answer in Celsius. Now when we're finished, it's going to give it in K. K is going to drop out, and we're going to have to convert it when it has a volume of 25. So it looks like that's the only conversion. I think we're going to be okay here. Volume equals 25 liters. The N is 203. That's given to us. So this is coming together quite nicely. R value, because we're dealing in atmospheres, is 0.082, and temperature is what we're looking for. So convert. No, thank you. I don't think I need to convert anything here, do I? All right, so none needed. I don't see any reason to convert anything. So all I need to do is rearrange my PIV-NERT, rearrange my PV equals nRT so that I have T, right? So that's going to, what's that going to look like? How about if I just say, what if I just divide this by nR? And then the T will be by itself over here, won't it? So then if I just said PV equals T over nR, that should work. All right, so the P is 143.5, and start with the parentheses, times the V, which is 25, divided by N, which is 0.082, times the N, which is 203. Excuse me, I reversed these two, but it's multiplication, so it doesn't really matter, does it? The N value is 203 and the R value is 0.082, but it's multiplication, so it's not going to be a problem. So thanks for understanding. I'm not going to rub that. I'm not going to rub it out. Equals 215.4, and remember that's K. Okay, so we just have to take our 215.4 and minus 273. Well, that's bigger, isn't it? So it's going to be a negative number. going to say negative 57.4 degrees C. That's cold. So that's going to be some cold gas.